The rate of diffusion of a gas Y is twice that of Z. If the relative molecular mass of Y is 64 and the two gases diffuse under the same conditions, find the relative molecular mass of Z. Solution. I would like to remind you to subscribe and click on the notification bell so as to get more of these videos. Going back to the question again, is a question on gas law that has to do with rate of diffusion of gases. And for rate of diffusion of gases, the law applicable is the Graham's law of diffusion. And Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its molecular density. And from Graham's law, we have R, which is the rate of diffusion of the gas, to be inversely proportional. This R varies as 1 over square root of the molecular mass of the gas. We have capital letter M representing the molecular mass of the gas, while R refers to the rate of the diffusion of the gas. So now in the question above, we are given two gases, gas Y and gas Z, and we are made to understand that the rate of diffusion of gas Y is twice that of Z. Since we are not given the specific value, we are just being told the relationship between those two. We are being told the proportion of the rate of the diffusion of the gases. So the best thing to do is to represent one of them, that is one of either Y or Z. That is to represent either rate of diffusion of gas Y or Z with a variable. And to do that, I'll be representing the rate of diffusion of gas Z to be X. So now let's say rate of diffusion of gas Z, RZ equals X. So let the rate of diffusion of gas Z equals X. So if the rate of diffusion of gas Z is X, definitely the rate of diffusion of gas Y, which is twice that of Z, will be 2X. Now we've just stated the proportion in which the rate of diffusion of the gases are to each other. Coming back to the Graham's law of diffusion equation here now. So we can then say that R, the rate of diffusion of gas Y, which varies as 1 over square root of My, that is the molecular mass of gas Y, is equal to 2X. For gas Z, we can then say that R subscript of Z, that is the rate of diffusion of gas Z, which varies inversely as the square root of its molecular mass, Mz, equals, let's have this well written so as not to mistake this. Okay, Mz equals X. So now to proceed, we'll be combining these two equations together. So now combining these two, we then have Ry over Rz to be equal to square root of Mz over square root of My, which is also equal to X over 2X. So what we did here now is that we've just combined these two equations together, that is the rate of diffusion of gas Y with that of gas Z. So now since we've combined the two equations together and here now we are having two equal signs, we can easily cancel out one of these three. I can say Ry over Rz equals this. I can say Mz over square root of Mz over square root of My equals X over 2X. Then I can also say Ry over Rz equals X over 2X. Either way is still the same thing. But based on the question now, we'll be nullifying this. That is Ry over Rz. We'll be cancelling this out. Then we now have square root of Mz over square root of My to be equal to X over 2X. So from here now, we can easily get the molecular mass of Z, which is what we are being asked to calculate from the question. Let's note that My, that is the molecular mass of gas Y, equals 64. So let's substitute the values. So now we have square root of Mz over square root of 64, that's the molecular mass of gas Y, equals this cancelling each out, we can have this as 1 over 2. So we have 1 over 2. That is x here now is now cancelling each other out. So we have 1 over 2. So from here now, to eliminate this square root, we'll be squaring both sides. So we have squaring both sides now. We have mz over 64 to be equal to 1 over 4. And from here, when we cross multiply, mz equals 64 multiplied by 1 divided by 4, which is equal to 16. And this serves as the final answer. We've just come to the end of the solution to the question, and we've gotten the answer to be 16. That is, the relative molecular mass of Z is 16. That will be all. Do not forget to subscribe and also click on the notification bell so as to be notified as soon as new videos are being released. You can also leave your comments in the comment section below. Thank you.